So we're going to continue on with combinations today. Um, and it's really the same kind of stuff we were doing in part one, just dealing with more restrictions, which is really what makes it a little bit more complicated. And also dealing with a deck of cards. Now, for some people, if you play cards, you're already very familiar with what makes up a deck of cards. We actually will be doing a lot of questions with a deck of cards. And the reason is that there are so many different groups in a deck of cards. You have 4 suits. So you could break up into groups according to suits: spades, clubs, diamonds, and hearts. You could make sets based on the face value of the card. So you could say make a group of 8s, make a group of kings, make a group of aces. And then there's colors as well. You could make groups that have black cards, that have red cards. And then there's also a special group called the face cards, which includes the jack, the queens, and the kings. So I know there's a lot of people who maybe do not know a lot about a deck of cards. So let's just have a look. Now, this is something, of course, you could find online, but I've also attached it. So when you're doing your practice work, and if it's about a deck of cards and you're not familiar with the cards, then I would suggest you have this open up on your device so that you know what we're talking about. So what I have here is, so it's important to understand that there are 52 cards in total. There are 4 suits. Now, the suits I've got down along the left-hand side right here. So you'll notice that each suit has a different symbol or a different picture on it. We've got clubs, which are black, hearts, which are red, spades, which are black, and diamonds, which are red. So half of the cards are red, and half of the cards are black. And within each suit, so within each suit, the clubs, for instance, has an ace, which is kind of like a 1. There is no 1 in this deck. We've got the ace, the 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these last 3 cards, these are the ones we call face cards: the jack, the queen, and the king. So if we look at the face cards, for example, in each suit, there are 3 face cards. Now, because there's 4 suits, it means that in this deck, there are 12 face cards in total. Every deck has 4 cards that have the same face value. So there are 4 7s, there's 4 3s, there's 4 jacks. But remember, each one of these cards is different because they come from a different suit. So even though I can say to you there are 4 9s, those 4 9s are not the same. You've got the 9 of clubs, the 9 of hearts, the 9 of spades, and the 9 of diamonds. So every card in this deck is different. There are 52 different cards, but then you have these groups of cards that have something in common. So you may want to keep this little sheet handy when we are doing our work. If you can print at home and ink and colored ink isn't an issue, then you might even want to print it off. But you can also just have it handy, look it up online while you're doing your work. All right, so they've pretty much in our workbook, what they did up here was kind of the same thing that I just showed you. All they're doing is telling you what makes up a deck of 52 cards. So we're ready to try a couple examples here. How many different 5-card poker hands are possible? So we're looking at making a 5-card poker hand. That's like saying how many different groups of 5. How many groups of 5 cards can be made? So no restrictions. We're not looking for any specific cards in this hand. So we're just going to say, well, how many cards are available? So 52 cards are available. And we are going to choose 5. And the reason this is a combination and not a permutation is that the order of the cards does not matter. When I'm waiting for my cards to be dealt to me, if they get dealt in, let's say, order A, and the same cards get dealt to you in order B, it's still the same group of cards and the order of the cards does not matter. So this is a combination. And there are 2,598,960 possible groups of 5. In how many of the hands in part A will there be all diamonds? Now, as soon as we're restricted to a certain kind of card, we have to think, well, how many cards of that type are available? So how many diamonds are available? So rookies, you might want to look back at this, and here's your diamonds. Now remember that there are 13 cards in each suit. And here's your diamonds down here if you want to have a look at them. So when I think, well, how many are available? There are 13 diamonds available, and I want to choose 5. So that would give us 1,287. So notice that it connects this to part A. So it says here, how many of the hands in part A will there be? So in part A, what we have here is every possible combination of 5 cards. And what we have here is how many of these, sort of all those possible hands, 1,287 of those will be all diamonds. Okay, so let's look at part 2 here. Now, this is going to be quite a bit like we did with permutations. I mentioned yesterday, very similar. What we need is a combination for each group that we're putting together. So we always have to think about what are the cards that we're putting together. Notice we've got the connector word and, so I know I'll be multiplying. So 4 black cards and 1 red card. So notice we are still playing with a 5-card group or a 5-card hand. All right, so 4 black cards. How do I get 4 black cards? So I look at how many black cards are available. So I can go back here and I can count the black cards. So the clubs and the spades are black. Remember, there's 13 in each one. I also had said earlier that half the deck is black, half the deck is red. So black cards, half of 52, that's 26. So 26 black cards are available. And I want to choose 4. And means multiply. Now let's work on our red card. 26 red cards available, and I want to choose 1. So another thing we talked about yesterday was almost a way of kind of checking your work in a way. If you add up the 26 and the 26, we get 52, right? And that's how many cards are available. And then if you add up the 4 and the 1, that gives us 5, and that's how many cards we are putting in the group. So kind of a little way just to pause and check and make sure that those numbers add up and make sense. So I'm putting this in my calculator, and I get 388,700 groups of 5 can be made that have 4 black cards and 1 red card. Now, I'm not going through and showing calculator steps because if you've been doing your work and watching the videos all along, you will know those steps, and I don't want to bore people, but if you need help on calculator stuff, please send me an email and I can help you with whatever you need help with. All right, so now we're on 3 kings and 2 queens. So let's work on, we've got 3 kings and 2 queens. So 3 kings. Maybe you want to pause and just give this one a try. Maybe you've got the feel for it. So 3 kings, I think, okay, how many kings are available? Now there are 4 kings available, and I want to choose 3 of them. So again, if we go back to our deck of cards, here's our kings. There are 4 kings available in the deck, and I want to choose 3. Okay, let's look at getting these 2 queens. How many queens are available? 4 queens available, and I want to choose 2. So again, I've got a combination set up for each different type of card that is going into this 5-card group. This one comes out to be 24. Now, people who know a little bit about poker, you're going to know that this hand, if you get 3 kings and 2 queens, that is a very good hand. The reason it's a very good hand is it can't happen very often. There's only 24 ways to get this hand. And remember what we did in this very first question. There are more than 2 million hands that could possibly be dealt, and only 24 of them have 3 kings and 2 queens. So that makes it a really powerful hand because it's rare. It doesn't happen very often, compared to this hand. 4 black cards and 1 red card. Well, that's really not anything too powerful in poker. Doesn't count for anything. And there's a lot of them. There's over almost 400,000 ways that you can get this combination. And so there's nothing special about it. It's not rare. And so it's not a hand that's worth a lot. All right, let's go on to part 4. This one, people sometimes think is a little tricky, but what you have to remember in this is that we're still making 5-card poker hands, or we're still making groups of 5. But they're only mentioning 3 of the cards. So in this 5-card hand, or this group of 5 cards, we want to have 3 kings. All we know about the other 2 cards is that they are not kings. They could be anything except a king. So my little planning step here, that little bit, slow down and just think about what would be in this hand. We're going to have 3 kings and we need 2 other cards. So if this hand has 3 kings, then it also has 2 non-kings. So a little line over top means not in math. So this is an easy way to say not a king. All right, so setting up our combinations. So to get the kings, how many kings are available? 4 kings in the deck, and we want to choose 3. And means multiply. Now think about the non-kings. So again, card players, this is probably easier for you. But for non-card players, all of these cards are the non-kings. So remember, there's 52 cards in the deck. These four right here, those are the kings. So 52 subtract 4 tells us how many cards are not kings. So 52 subtract 4 is 48. So there are 48 cards that are not kings, and I want to choose 2 of those. Put it in my calculator, I get 4,512. So if we were comparing hands, which one is a better hand so far, and you think about how rare a hand is, how hard it is to get because it's rare, and the ones we've looked at so far, this one would be the best hand because it's not an easy combination to get. It's a rare combination. This would be the next hand as far as what it's worth, all in one suit. So not just because it's diamonds, but if it was all hearts, it'd be the same. If it was all spades, it would be the same. This is the next best hand. And then this would be 3 kings along with any other cards would be the next best. And like we said, this one right here, not really a poker hand at all. It's just kind of a nothing hand. All right, so let's see if you can do part 5 on your own. So if you're feeling confident about it, pause and try part 5 on your own. Now remember, we're still making groups of 5. So when it says our group of 5 has to have 4 aces, we have to think about, well, what is the other card then? So here we're looking at 4 aces and 1 non-ace. So think about how many aces are available. 4 available, and we are choosing all 4 of them. And is multiply. Now the other card could be anything except an ace. So I know there's 4 aces in the deck. 52 subtract 4 means there are 48 cards that are not aces, and I want to choose 1. And I plug it in my calculator, and I see there are 48 different ways to do that. Now, these answers that we're getting, I mean, it is much easier to see or to understand what we're finding if we actually saw this. So let's go back here. I'm not going to try to draw it all out, but let's go back to this hand right here. We said, it's a pretty good hand in poker. There's over 2 million hands that could come up. And this one, there's over 4,000 ways of making this hand. And it's not a bad hand in poker. So when we say there's 4,512 ways to do this, like what exactly does that mean? So a group of 5 that has 3 kings. So we're going to go back into our deck of cards, and I'm going to try to demonstrate what that would look like. Because you might be wondering, well, how are there so many if we're just talking about 3 kings and another card? So let me try to demonstrate here. So in one of those groups, we could have these 3 kings and this card and this card. So that would be one of those groups. And then in another one of them, we could have these 3 kings with 5 of diamonds and 3 of hearts. There's another group. And we could have these same 3 kings being dealt with the 4 of clubs and the ace of hearts. So you start to see why there are so many. Now, even within our 3 kings, let's say we have this king, this one, and this one. There's a different group of 3, along with this card and this card. That's a pretty good hand, actually. It's a full house. But if we actually were to try to list these out, we said there's over 4,000 of them, so we won't. But it's just important to understand, like, what does it mean by this group? So let's pretend for a moment, just one more. Let's pretend our group of 5 has the king of clubs, the king of spades, the king of diamonds, and the 2 of hearts, and the 10 of spades. There's a whole new group of 5. All you have to do is switch out one of those cards and you have a different group. So hopefully that explains, why we're looking at 4,512 different groups of 5 that have 3 kings. And then our last example today, we are looking at a little trickier because they're breaking it up into more possibilities. There are some ors involved in here. So sort of like with permutations, when we felt like there was something missing, like they're being very ambiguous. I don't know how to get this going. They haven't given me enough information. Just like we did with permutations, we have to include all scenarios. So here we're saying we're looking at 5 cards of the same suit. Now, you don't have to know these words, but in poker, that's called a flush, and it's a pretty decent hand. So if we look back, we did look at this one back in this stage right here. All diamonds came to 1,287. So the thing about the difference in this one is they're not saying which suit. So let's just think about all of our scenarios here. You could have 5 hearts or 5 diamonds or 5 spades or 5 clubs. And of course, I run out of room. So now we're looking at a connector word of or. We've learned that or means add. And then let's look at our combination. So 5 hearts. Think how many hearts are available. There are 13 of each suit. So 13 hearts are available. And I want to choose 5. Okay, diamonds. 13 hearts available. And I want to choose 5. And the same thing for spades. 13 spades are available. We want to choose 5. 13 clubs, and I want to choose 5. Sorry for the squishy writing. Now, if you want a quick way to put this in your calculator, because we know that each one of these is going to give us the same value, and I also know that's a lot of buttons to push. So I think the way that I would do this question as far as on my calculator is I would go 4 times 13, choose 5 for a quicker way, and we get 5,148. All right, ready to practice. But don't forget, you're not trying to learn all this stuff on your own, so let me know if you need help. And you guys who don't really play a lot of cards, make sure you've got the sheet with the cards available so that you're not just guessing. Use that sheet, get in there and count.